The Institute of Physics of the National Autonomous University of Mexico, IFUNAM, is at the forefront of research and graduate academic programs with a well-deserved international reputation. IFUNAM is unique because frequently innovating ideas and projects of value for society emerge as a result of the work at IFUNAM. Research at IFUNAM comprises a vast range of topics in experimental, theoretical, and applied physics, with outstanding results in cosmology and high-energy physics, optics, atomic and molecular physics, condensed matter and nanoscience, nuclear and medical physics, as well as complex system and statistical physics.
IFUNAM was the first place in Mexico where we have been doing nanoscience. We have a very strong groups in theoretical nanoscience, computational nanoscience. We have been at the beginning of different fields. One, for example, is plasmonics. We figure out that the nanoparticles are not spherical nanoparticles, as people try to simplify all the time. And for example, we have done a lot of contributions of the electronic and optical properties in terms of the different shapes of the nanoparticle, real shapes.
The facilities that we have are such that have no parallel in any other university in Mexico. An example that is dear to me is that we have 5 particle accelerators in this institute. Accelerator mass spectrometry, it's the highest sensitivity technique that humans have developed ever. The kind of research that we can do here is also unique. It really pushes the limits of knowledge in areas like from archaeology to nuclear astrophysics.
In the optical micromanipulation lab, we have different research lines and of course different projects. We study the interaction of light and matter. We studied the optical trapping forces in different contexts and with different kind of optical wave fields. We try constantly to be at the borderline of knowledge in physical sciences.
IFUNAM has an important laboratory infrastructure, including 3 national laboratories.
The National Laboratory for Quantum Matter brings together several research groups from more than 10 institutions from all over Mexico. The specific objective of this national laboratory is to study and investigate different aspects on quantum mechanics. In the case of my lab, I'm in charge of building and constructing the first experiment in our country to produce and study ultra-cold quantum fluids.
Mexico has a huge and very important cultural heritage. We focus on the material examination, the material study of the cultural heritage. I mean, we use all kinds of methods from physics and other sciences in order to know more about these objects.
The high-altitude water Cherenkov detector HAWK is one of the unique research institutions in our country. We want to study the highest energy gamma rays that come from the universe. So we have built a detector of more than 300 large water container detectors that have 200,000 liters of water with which we detect the particles as they impinge on them. They emit flashes of light that is called Cherenkov light, and by detecting that and reconstructing the arrival times, we can reconstruct the direction of the original gamma ray. That way we can make gamma ray astronomy with this unique detector.
In this institution we don't have a lot of pressure to publish just because we need to publish. We have time to think, and this is very important because then we can do more significant contributions.
Well, at its 80 years, the Instituto de Física is one of the oldest and also one of the best institutes in science in Mexico. And it's one of the driving forces for research in our country.
We foresee an integrated institute in which academics and students increasingly contribute to the understanding of the universe and help create knowledge and technologies that benefit our society.